live, so I'll just print this out for you, Alex, because that one needs to be jammed together. 91165.
Smile. Okay.
All right. Get this guy out. Print. Done. This is a much better camera. We'll see. Has John joined us yet? Oh, one viewer. Is that you, Alex? Don't you have your thing today? Well, welcome whoever's there. 2 viewers. Good. Science with Folly. I'm just doing a couple of things here. Whoever's listening, sorry, there's no good image. You can talk to the guys over there. Yeah, it's looking at you, Sam.
How's it going?
Oh, 3 viewers now. You on there, Sam, are you? There you go. We're going to get some feedback soon. Yeah. Now, where is? Oh, just give me a second. Classroom. Turn it off, sir. Yeah, I'll put my link up here.
It's so delayed.
It is.
Well, it has to be delayed.
That was boring anyway. I didn't learn anything.
What?
Where?
You're right. Did you put a comment up, have you?
Me?
Yeah.
No?
Cool. I'll just get you one for you, Alex, then we'll get into it.
Pretty sure who's in it.
He needs to put on his Science with Folly page that he's here. Or his, not his page, his Facebook.
Oh, what? I don't know. No. That's the wrong chat. Chat that's 4 minutes. Save it to watch later.
Right, read there.
So Jen, we're trying to get our body around the situation that regular fever doesn't count for carbohydrates.
All right.
Right, and then one comment, break your arm.
There we go.
You can still get it wide. Still get it wide.
There you go.
I know you.
Who's carrot in the pot? Are you Sam? All right. So now we're down to 1 viewer. Is that just you, Sam? Are you still on there?
Yeah.
Oh, no, 2. There we go. So, there's 2 viewers, so that must be John, is it?
That you're on.
No, but I don't think any of the students No. I don't use Facebook.
Yeah, Facebook is like for old people now, eh? Didn't you know that, Sam?
Yes, but it's
Oh, we've got 3. Please identify yourself if you're on there. I've got carrot in the pot. Who else have I got? John, are you there? Olivia, are you there? Is anyone else there? Otherwise, I might as well just turn this thing off. Because we're about to get started. Oh, I need mine.
No, let's see how much knowledge you have on year level 2 chemistry.
Oh, Olivia, you are there. Very nice. Good to see you, Olivia. Okay. Hopefully you've printed out this 2018 exam, and if you haven't, there is a link to it. I will just make this a little bit. There you go. Sweet. So yeah. Chemistry, organic chemistry. We'll start with that first question. Sweet, guys. No. So we've got some compounds we have to give the names for. Sweet. So we've got first one. Have a go at those, then I'll go over them with you.
1, 2, 3, 4, 5 C's. So that's pent.
Very good. 5 C's is pent something.
And then there's a double bond.
Which is on number. Which is what position? Where's the double bond
I
position?
don't remember how to do that.
Pent.
1.
1. Ene. Look
Wait,
at
why is it E?
Because it's a double bond.
because the double bond.
It's an A. Yeah.
So that's our group is the double bond. Our next one, we've got a methyl group and an OH group. A straight chain is 1, 2, 3, 4, but we count from which end? So, but we also use wherever we get to the OH first. So it's actually the other way around. It's 1, 2, 3, 4. And just to remember, sometimes you have to check this is just a CH3. You could have had a C2H5 just to trick you, and then that would make it the longest. So we've got 4 in our chain, so it's bute, and it's butanol because it's an alcohol, butan 2-ol, and the methyl group comes off number 3, so it's 3 methyl bute and 2-ol. Is that what you got?
Why does anyone do this? Okay.
Oh, sweet, we've got Ayla here as well.
And stupid robot fighting.
John, do you want to learn some chemistry? Good on you. Yeah. No, this is another John. Good to have you, John. Let's have a look here. So now we've got 2-hydroxyl propanoic acid. Right. How do we draw that? Prop is how many carbons? 3. So 3 carbons. 1, 2, 3. Double bond to the O. OH. What's a hydroxyl?
Hydrogen and hydrogen 1.
No.
Or is it a
Because they're all hydrocarbons.
So the answer there, hydroxyl, this is an annoying one. Because it can't be an alcohol because it's a carboxylic acid, it's a hydroxyl is an alcohol group, an OH group. And so it's coming off number 2. So it's OH there, C, C, C. Chemistry in the context of beards. What does that mean, John? I have a beard. See? You can't see it real well. Anyway, it always looks worse from a terrible angle. Now, so cool, let's go down to the next lot. Draw structural formula. Oh, sorry, you can't see that. Draw structural formula for primary, secondary, and tertiary chloroalkane molecules that are the constitutional structural isomers with a molecular formula C4H9Cl. You're going to do it on the board, Sam? Well, you better rub first. You better rub that off. You've made a big mess on the board. Sam is going to try and do it on the board.
Don't show people.
Look at my board. It's a disaster. But I can't hold this thing very well. How do I position it? Look at that mess. Oh, sorry. I thought you were going to do it on the board. I'm not the judge. I'll set you free though.
Oh, so
Na 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 na. Next. Hey, you and I are 21 pilots, like buddies, you know? Okay, here we go. Structural formula. C4. 1, 2, 3, 4. Chloro coming off number 1. Now it could come off either end. So that's my primary. It could come off here, 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 here. Secondary. I'm just putting it there. But it could come off anywhere there. So secondary has to come off either here, 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 or here. And obviously tertiary is this one here.
that's a cheeky one.
Yeah, it is. So our first one, what do we call the first one? Well, you guys are ahead. What's that name?
One chlorobutane.
Yeah, 1-chlorobutane. Next one is 2-chlorobutane. And what's that last one? No, yes, you're very close. What comes first? Chloro, because it's a C. Yeah. So this one here, 2 chloro, 2 methyl propane, sweet as. So just don't forget that, guys. Don't forget that. Go over the page. Perspex. Oh, there you go. I didn't know this. Did you guys know that? Perspex is that stuff that looks like glass. It's a polymer used as an alternative to glass because it's transparent, lightweight, and shatter resistant, but it scratches easily. Like my watch, it's got scratches on it already. It can be made from the monomer shown below. Now, in the box below, draw 3 repeating units of the polymer found. So we haven't really seen this, but remember, all we do is break that double bond and stick it out each side. So we've got H, H, C. Here, it gets a bit tight here, so you can kind of extend that. Doesn't matter. H, H. And there you go, I've got my 3 units. You guys managed to fit it all in there? It's a bit of a squeeze, eh? Let's have a quick look. I'm sure you've got that. You don't have to have the brackets, just the dot, dot, dot. You only use the brackets if you're doing one monomer and you put it in down below. Good joke, John. You must have seen the H2SO4 and sugar one. That would do the trick. Justify whether or not the monomer used to produce Perspex is geometric cis-trans isomer by explaining the features required for this type of isomer. Hey, someone's just gone to my class with fish and chips. What's up with this? You're disrupting my live stream. Someone online, tell me. Just over this, so is this molecule here a geometric cis-trans isomer? Is it or isn't it? Come on, Ayla, Olivia. Cis or trans, is it or isn't it? Just look at this one here. What do you guys say?
I don't know because the double bond is with the first carbon, so it cannot be.
You are right, Alex. Since no one online answered my question, this can't be a cis or trans isomer. It cannot be a geometric isomer because the double bond is attached to the first carbon, and we've got 2 hydrogens there. Then afterwards, that there, it doesn't matter which side it's on. If you want the full answer, there it is there. The monomer forming perspex is not a geometric isomer. Geometric isomers must have a double bond between 2 carbons which prevent rotation. This monomer does not have this, but the other feature of a geometric isomer is, this isomer does have it, but they must have 2 different atoms or groups of atoms attached to them. So a bit of a long, that's an excellent answer, but hey. Thank you. I hope you went to Hong Kong.
Yeah.
Oh, good. On you guys. I can say that. Gary wasn't here. Right, just got me some hot chips. Yay.
That doesn't matter.
Money laundering.
What? Are you accusing them of running a Chinese laundry, are you?
Well, apparently, man.
Right, let's turn the page. You guys on to the next page yet? Oh, okay. No worries, I'll give you a minute.
Tony is a mafia boss name. Mafia controller. Therefore, all ginger cats are part of the mafia and criminal gangs and.
Right. Over the page, Alex, are you? Oh, yeah, over the page. Okay, let's go over this one. When butyne is reacted to form bromobutane, C4H9Br, 2 organic products are formed. Sweet, we've got something going on here. Analyze this reaction by stating the reagent required, identifying the type of reaction, and explaining why there is a mixture of organic products. So first of all, what's the reagent?
HDR.
It already is. Oh, sorry. Oh, BR. So yes, you're right. It's. Oh no, it's not bromine water. It's HBr. Yeah, hydrogen bromide. You don't have to call it hydrogen bromide. Just remember it's HBr. Then, next thing, what type of reaction is it? Butyne, remember if we draw it out, has got a double bond, so it's got less hydrogen to bromine, so it's going to be a, what is it? Addition reaction, because they're adding in molecule or atoms. Addition reaction. And lastly, explaining why there is a mixture of organic compounds. Okay, why is there? What's the key thing? Yep, because the bromine could go to which carbons? Carbon number 1 or 2, yep. Attached to carbon 1 or carbon 2, forming 1 bromo butane or 2 bromo butane. So you've got to just say, can attach to carbon 1 or carbon 2, give the names, and then discuss. You would say there is a mixture of products. John. There is a mixture of products because I've used old Markovnikov of Markov. Do you remember that? Markov. No. I hate that guy. I can never spell his name. Markovnikov's rule. And what's his rule, Haley? The rich get richer. But that is not actually the case in the real world. We should know that from Adam Smith, that the rich don't always get richer. Unless you... And then we draw the reaction in our space below.
You guys want some chips? Some potato fritters?
This is a test for Alex.
What's the challenge? The challenge. BKCHATF. Change must be equals.
So when I was living in Hong Kong, I felt like getting some support and I agree with my decisions. That's why I was like, just go first. Go first.
More sorry.
And there we go. This one here is 1 bromo butane, 2 bromo butane. Which one? Name for me the major.
2 bromo.
Good. So this one here is our major product. And this is our minor product. Because remember, this carbon already had 2 hydrogens, so he got richer by getting the other hydrogen. And this guy just stayed poor. Whereas this is the minor. Sweet. Actually, probably bromo up or down, wherever you like.
One bunny chicken or a very oily onion ring? One oily onion ring?
I think I'll pass. That's okay. Right. Look at the page. Two bottles of different colourless organic liquids are unlabelled. Which one are you going to drink? They are known to be propan-1-amine, CH3CO2, and ethanoic acid. Aha, I know which one I would drink. Actually, we could do with some ethanoic acid right now for those fish and chips, eh? Because what's the other name for ethanoic acid? Vinegar, very good. Explain how you could identify these two liquids using only solid sodium hydrogen carbonate. What's the other name? What's the common name for sodium hydrogen carbonate? You use it in cooking. Baking soda, yeah. NaHCO3, baking soda. So, What are you going to do? This is super easy. How can you tell which one is which? Yes, ethanoic acid, which is vinegar, when you add sodium hydrogen carbonate, it will fizz and bubble. When you add sodium hydrogen carbonate to propan-1-amine, nothing happens. Sweet. Because they're both, this is an acid, this is a base. To get maybe merit, you might just want to explain what kind of reaction is it? Acid and base is it's a neutralization reaction, and what's the gas that would be released? Carbon dioxide. Sweet. So that's the key thing there. So I'll try to give you a minute to write that down. You guys online are pretty quiet. No questions there, please. Stick a question if you've got any questions about this.
Anything like me that just slow type doesn't and need to like write out things while you say,
Or like you didn't even know how to type on YouTube.
I could, I mean, from my own account. Just so it's listen.
Right. You on to the bottom one, guys? So give the structural formula and name for the product of the reaction between propan-1-amine and ethanoic acid to form a salt. Do you know what that is? This is a hard one. When sodium hydrogen carbonate breaks up, it forms two ions, sodium ion and a hydrogen carbonate ion. So it's Na plus and HCO3 minus. So, and when propanamine, do you guys know where that goes? What happens? This is a hard one, eh? It's like, what actually happens is that if I draw it out in full, I'll just do it like this: CH3, CH2, CH2, but then an H from the, because I was looking at the wrong thing. What an idiot. Ethanoic acid, it forms CH3COO minus, and then you get the H plus. So the H plus goes to, and so you get an NH3 on the end. You with me? So it becomes C3, CH2, CH2, NH3. And because it's got the extra H, it's got a positive charge. And then you've got the CH3COO minus. So remember, what do you call it when a carboxylic acid loses its H on it? An O8. So it becomes ethanoate. So it's propyl ammonium ethanoate is the name, because we've got propyl ammonium ethanoate. Oh, that's good, Ayla. Hopefully that one makes sense to you. Oh, yeah, you can just draw the like reduced structural formula. Yeah. That's fine. Okay, yeah. Oh, that is, yeah. After lunch, I could do a bit of bio, because I'm still here. Like, even at lunch, I can be here. I was going to chat to you right now.
Yeah, that's a break. You guys gonna do something?
I take off to get up anyway.
Well, I'm still being a Boston anyway.
I'm not done. You guys want to do?
Oh, yeah, you're on your boy now.
Oh, yeah, right there.
You're like debating, you can get like,
Why does my camera get this?
Like, it will be a little detail.
Sam, when you go on the thing, do you get all these lines showing up on your screen?
I don't think you need to write the one when you read it. Right? I think it's just
So LED lights.
I want LED lights.
Oh, from the booking. You need to Google his, click on his link and it'll take you to his YouTube channel. If you're lucky, Sam, you might even be able to get some merch from John. See his see his logo there? Yeah. I don't know if he's got merch yet. The Stupid Robot Fighting League, you see. Do you have any merch yet? Oh, he has got merch. Sweet.
Jonathan! I missed the explanation.
There you go, that's better. All right. What are you talking about? Oh, should I make it private, should I? It's harder to get to, because if I don't send a link to someone, they'll get locked out. I'm not doing anything untowards in here. I mean, who wants to watch a chemistry video? I mean, really? Okay. Three more unlabeled bottles of colorless organic liquids are known to contain hexane, hex-1-ene, and ethanol. What? So only one of these is, they always give you only one that's relatively safe to drink. Hexane and hex-1-ene would be very nasty to drink. Ethanol, people under 18 shouldn't be drinking that. So, write a procedure to identify each of these liquids using only bromine water and water. What? How are we going to do this? Okay, before we write anything down, which one can you identify using bromine water? Okay, hex-1-ene is the main one using bromine water because what will happen? Will it react? Yeah. So bromine water will react straight away with hex-1-ene because, and it will turn bromine water clear because bromine water starts off brown. Slowly, yeah. UV light, yeah. So hexane will turn brown but turn clear, but after a long time. So if you've only got a minute, it's just going to be the hex-1-ene that's going to go turn it white. The hex-1-ene won't. How can you tell? Well, you see, if you don't have enough time, How can you differentiate? It's easy to differentiate hexanine. How can you differentiate hexane and ethanol? What's your other substance you've got there? Water, yeah. No. What happens when you put alcohol into water? What happens when you put alcohol into water, girls? Let's get a bottle of wine. Tip in some. No. Nothing happens. It just dissolves because alcohol is soluble in water. Because alcohol and water are both what kind of molecules? Polar molecules, exactly. So yeah, put the alcohol in the water, it'll dissolve. So we can't identify the alcohol. We can identify the hexanine, but we can't if we don't have enough time. So, but what if we put the hexane in the water? What's going to happen then? It forms a layer. Fantastic, because hexane is non-polar. Excellent. That's good. So you need to include equations in your answer. So brown. So write something down. Brown, bromine, water becomes colorless in hexanine. Straight away, maybe put straight away just to specify. Then do your equation. What's the formula for hexanine? How many carbons? C6. How many hydrogens? 12. So C6H12 plus Br2 gives you C6H12 Br2. And what would the name of it be? If it comes from hexanine, what would the name of when it's reacted with bromine, what would it be? And where would the bromines be? Good, 1,2. 1,2 dibromohexane. Sweet. The next one, you would say hexane forms a layer on top of water because hexane is non-polar and water is polar. Therefore, they are immiscible or something. You don't have to use it. Immiscible just means they don't dissolve in each other. And lastly, ethanol is polar, so it will dissolve, or it is soluble in water. Is that cool? You got that? My writing's probably getting a bit messy for you guys online. I'm very sorry about that.
Is this going to be announcing, like G+ stuff?
Yeah.
How do you work those out again?
You just count. It probably won't be there. Just the concept of it will be. How are we going? Need to finish this in time. You guys up to question C? You've written enough there, Alex? So many organic reactions take more than one step in order to convert from one organic molecule to another. 2 steps are required to produce pentan-2-amine from an alcohol. Use the information given to analyze the reactions. Draw the structural formula of the compounds and name the reagents involved. So we've got one of these boxes. So first, alcohol. What's the alcohol going to be? Good, it's going to be pentan-2-ol. Which is 1, 2, 3, 4, 5. Doesn't matter where you put your. I'm going to stick it here. There's my first one. Do you know what the second molecule is? Because you can't go straight from an alcohol to an amine.
I think it turns into an E.
No, it just swaps something out, because what is more electronegative than a hydroxide or a hydroxyl group? Halogen, good. So halogen comes along, and what's the common halogen that we normally use? Chlorine, good, excellent. So the reagent, remember we've got lots of options there. What is it? We've got SOCl2, PCl3, or PCl5. I'm just going to chuck in PCl3, and the OH gets, what kind of reaction is it? Swap one out for the other? Substitution, cool. And so we get this going down. 5 of those, and the Cl's gotten swapped out. In the exam, if you get stuck, I mean, you can at least draw the first one, you know that it's pentan-2-ol, and then you'd be able to draw the pentan-2-amine. So if you get stuck on that middle one, it's still not the end of the world, because we know that this one here is, I put that guy in the wrong place. This is 2-chloro-pentane. And what's the reagent for making an amine? And how does it have to be? What's it in? Alcohol, yeah, it has to be an alcohol, because if it's in water, the OH group will not swap out for it. Does that make sense? Because that's why you can't go from straight to an alcohol to an amine, because the OH has got a stronger attraction than that. That's why you have to get rid of the OH group, when the chlorine has this different, stronger attraction, and then you can put the NH3 in. Lucas 3, that's what it says in there, right? But it's pretty hard to remember that, if you can. But probably if you didn't put the alcohol, but you might, yeah. What's another name for pentan-2-amine? How else could you write?
2-amino-pentane.
Very good, 2-amino-pentane. You might get given that one there. Elaborate on the reaction scheme. In the scheme above, in your answer, you should identify any conditions needed for each step of the conversion. names of alcohol X and organic molecule Y. We've done that. The type of reaction. Oh, sweet. Well, that's pretty easy. I've named them both up there. So conditions for the first one, well, just has to be liquids. The names of alcohol X is pentane 2-ol. The reaction type is substitution.
So far.
Second one, the organic molecule is 2-chloropentane. Yet again, it's another substitution. Both reactions are substitution. You got that, eh, guys? Both reactions are substitution. So yeah, are you coming back? Oh, I'll miss you, Sam. Thanks for the chocolates. Yeah. I'll see you on Monday, maybe, yeah? When's that when the buy? You don't want to come for some revision on Monday? All right. Oh, well.
I will.
You can go online. I could do a live stream just for you.
Maybe.
Or send me a message if you want me to do a live stream when I'm working with Hayley. Sweet. See ya. Oh, sorry, you guys can't see that. So yeah, first one, pentane 2-ol is a name, substitution is a reaction, 2-chloropentane substitution, and the conditions for that second reaction is NH3 has to be dissolved in alcohol. And that's because if it was aqueous, this is for you, to get the excellence, you'd have to say, because if NH3 was aqueous, the hydroxyl group would take the place of the chlorine and it would end up being, pentane 2-ol again. Sweet. What's that? That's what it says in the marking schedule, doesn't it?
No, because you don't need.
It's not just the marking schedule, isn't it? You've got to somehow allude to that. I mean, you might get an excellence without it, but just to be on the safe side, eh? Hey, Altaf's coming back to school soon. Yeah. I'll turn the page. Right, you over the page sheet, guys? Alex, so that's easy, yeah. The trends, there's two trends here. What are they? Roll around, yeah. Yeah, so, hey, as number of C atoms in chain increases, boiling point increases, but solubility decreases. Easy peasy. So solubility decreases, boiling point increases. Oh well. Sorry, John, I can't do a video on fixing trailers. Maybe I should get the metalwork teacher to do a live stream on welding for you. I think Mr. Bailey would be interested in that.
Need to wear the
I'm not sure how good the camera would pick up the sparks and everything. Right. So reacting 2-chloropropane with potassium hydroxide can produce different products due to different reactions occurring. So elaborate on the reactions of 2-chloropropane with potassium hydroxide. So what's going on there? What's the... Yes, that's right. So obviously the conditions are if KOH is aqueous or KOH is an alcohol, you'll get two different things. So remember, if I've got space to draw the diagrams. I'll do it here. You could do this whole answer as a equation. You know, you can just go 2-chloropropane, which is C. Chloro is coming off number 2, and you can then go arrow KOH aqueous. And if it's aqueous, what does it produce? Yeah, an alcohol. Remember, if it's aqueous, it produces an alcohol. If it's dissolved in alcohol, it doesn't produce an alcohol, remember? So yeah, so you're going to get this here.
That door.
Because remember that the potassium and the chlorine go together to make KCl. But remember, we don't have to write the KCl in there because the whole thing's still in solution. So the K and the Cl ions are still just floating around. So what's the name of it when it's got the OH down the bottom? Yeah. Propane 2-ol. Sweet. And then same thing again. There's the bell. KOH and alcohol. So what happens when it's an alcohol? That's when it becomes the alkene, yeah. Because I'll just close that door. Animals run fast. I'm not wrong.
You're not wrong.
So the next one here, it becomes an alkene because remember what happens? Yeah. So we get a double bond forming. Like that. You could have had the double bond either end because it's always just going to be one or just propene because you never have. That's what it is, just propene. And obviously you get, because the K goes with the Cl forming KCl and the OH goes with H2O. Sorry, the OH goes with H forming H2O. The first reaction, what kind of reaction is it? Good, substitution. And the second one is an elimination. So the first one, this is a Substitution reaction. Can I squeeze it in here? Substitution reaction. And this one here is an elimination reaction. You guys still watching? It's kind of lunchtime, but I'll do the next, looks like we've still got 6 watches, assuming that. No, I'll shoot off soon and get one. We've just got one question to go, and then, but for all I know, these guys might just have me on the background while they're playing games. All right, this one here. So back to part 1. It says, elaborate on chemical tests that could be used to identify the functional groups of the organic products formed in part 1. So you've got propene and propanetol. That's easy. How can you tell the difference between propene and propanetol? What are you going to use? For propene, you're going to use, you could use bromine, and when you add bromine to it, the bromine will go colorless. But if you add bromine water to the alcohol one, nothing's going to happen. You could use dichromate, and that will, for the alcohol, which will oxidize the alcohol, remember? And that will make it turn orange to green. But yeah, I'll put this up here, but it's not a lot there. But so yeah, identifying, use bromine to identify the alkene and dichromate to identify the alcohol, and that's it. Are you guys going to stay for a bit more, or are you going to call it quits after this? What's that? You'll go, yeah. Because I can stick around for you, Hayley, after I come back. Did you want me to do something?
I was just still going to stand still until still finished.
No worries. All right.
That kind of forces me to do
I'll say goodbye to everyone online. There you go. Hope you learned something today. Yeah. Well, this is a bit weird to just be looking at my hands the whole time. So, did you guys want to say goodbye, Hayley? There's Hayley. Goodbye, Hayley. Sam and Alex. See you later to John and Ayla and Olivia and yeah. Oh, Alta, you still there? Yeah, he might still be there. So if you've got any questions, those of you guys who are in my class, don't forget to go to the the Google Classroom there, and yeah, you can probably, I don't know, add some more comments to this. I'll leave this thing there for a while. Yeah, that's it for now. I think you guys got your exam. When is it? Period. Afternoon, eh?
Yeah.
Afternoon. So if any of you guys in the chem class want to come in, I never advise studying last minute, but if you do want to come in period 2, I could possibly help you. So 10 o'clock-ish. If you want to do some last minute stuff. All right. That's all. Ka kite anō. You have to finish with this.